So we got started with our 2.2 and I got halfway through and the bell rang. So I decided to go ahead and just start over for you, for RJ and Emma. I wanted to go ahead and give you a lesson that keep in mind we won't have school on Monday. So you could go ahead and get kind of caught up. That'll be a work day for us. And so I'm trying to get a little bit covered so that on Friday, Mineola will also have a work day. Just let's go ahead and get started. Today we're going to go over on the 2.4, which is more functions. Now remember, we talked about the domain last unit with being the x values. And then the range is associated with the y values. And today we're going to talk even more about kind of the nature of graphs, and that's what this chapter is kind of going to be dealing with. The first one we're going to talk about is going to be just whether a function increases, decreases, or is constant. And again, the way I look at it is always looking from left to right. And so they think about it in terms of if you're walking on the top of the graph of the function and you're moving from left to the right, are you going to walk uphill, or are you going to go? That would be increase? That's going to be decreasing. So again, always left to right, and then that it's pretty easily to determine whether or not you have an increasing graph, decreasing, or whether it's constant. Now, some of the ways that we will be writing this. So again, it states the interval. So we're going to write this in interval notation on the functions where it's increasing, decreasing, and then constant. So let's start off with increasing, and I'll just put INC. And so again, from left to right, if I move my pen and I start going up, I'm going to be going uphill all the way until I get to this function, or this value right here, when x is equal to -1. And so what I'm going to do is I'm going to start off with, I'm looking at the x values, and so those are going to be all the values left to -1, which would include negative infinity. So in other words, you're going to just go negative infinity all the way until you get to -1, and then you're actually going to stop and they're going to start going down again. So in this case, when you do your interval notation, remember you always put a parentheses with the infinity, but then at -1, honestly, I really feel like it's best since it goes from increasing to decreasing, and at some point it's going to be right there at 0 where it changes. I would rather you put a parentheses here, but again, I'm not going to be upset. If you put a bracket on that, I'm not going to count it incorrect. Decreasing means it's going to go downhill, and so if you look, my graph is going to go downhill until it gets to the point right here at 1. And so I know that my range is going, or my interval, excuse me, would be from -1 to 1, because I'm going to be talking about the x values. And again, I'm going to put the parentheses around both of them, because right at that point, at some points, it's going to just go, it's going to change. And then if you look at the constant, now, and this is the graph where it just is going to level off. And so from this point at 1 on, you're going to notice that it's going to be flat. And so that's a constant function. So in this case, I'm going to start off, remember, from the left to the right. So it's going to start at 1, and it's going to go to infinity where it's going to be constant. And that is representing this section of the graph. Again, I'm going to put parentheses. I always put parentheses around the infinity, but the 1 I would be flexible on. Now, the other parts that we're going to talk about today are going to be relative maximum and relative minimum of your graph. Now, the relative minimax mean that they aren't the actual minimax, because when I had like a parabola function, and for instance, if I draw this one right here, and I have a parabola, then this is going to be my smallest point. So this would definitely be a definite minimum value. But if you notice on the example that we have over here, the relative min means that right around there it changes. It goes from like decreasing to increasing, or from increasing to decreasing. But obviously these tails are going to be represent that they're going to go on for infinity. And so in reality, there's no actual maximum or minimum value of this graph, but there are relative mins and max, and that's what these points would represent. So when I look at my next part, this is the graph of the equation 2x to the third minus 6x minus 18x plus 8. And it says use the graph and state where the relative min is, or maximum, and the relative min is of the graph. So let's start with the maximum. So again, again looks like it's going to continue on and out, but so the maximum is not going to be a true maximum since this continues, but right here it's going to show that I go increase and then I change and I decrease. And this is also the point at -1. So again, I'm looking for the value that it occurs for the x value. So at -1 there's going to be a relative max. So I also put relative REL max would be then at -1. I would also say that it occurs, the y value in this case would be at 2. So I'm going to put the point then 2. So -1, 2 is a point. Sometimes on your homework assignment they'll ask you what the x value is, so the relative max, and if they ask just for the x is at x equals -1. If I do the minimum, then I'm looking at this value, and so then again I'm looking for what point is this looking like. And so it looks like it comes over 1, 2, 3 for the x values, but then it goes down 1, 2, 3, 4, and 5. So this is the point 3, 5, and that's also going to represent my relative minimum on that. Then with the types of symmetry we have, we have 3 different types of symmetry. One is going to be about the y-axis, one will be about the x-axis, and one will be with respect to the origin. In other words, in this case, if the respect to the y-axis, it looks like if I had a mirror right at the y-axis, it's going to look the same, or a mirror image from that. On my x-axis, it's going to be the same thing. It's just going to flip on my horizontally and vertically. But then on my respect to the origin, it's like it shifts, it rotates from one to the next. Some of the key features, if it's going to be has symmetry with respect to the y-axis, then when I have the value of x and negative x, it'll have the same value of y. The symmetry with respect to the x-axis means that I will have the same x value, but my signs for my y will opposite. And if you notice respect about the origin, I have an x and a y point. That means I'm going to have the negative x and a negative y as well. To define that, okay, so way to look at that, again, one of the key factors of the symmetry occur when you have a squared term. So what I'm looking for is what variable is going to be squared. Because when I substitute the negative x in for the expression for f of x, then I know that if I have it squared, that it's actually going to change, and it's going to, it'll make it be positive again. So in this case, if I'm looking for this, I'm looking for the y value that's actually going to be then the squared part. So if I put a y into that, so if I put negative y, so I will have x is equal to negative y expression squared plus 5, then I know that what happens is x is going to equal then y squared plus 5. This is going to represent, because of the fact that it changed the x, when I substituted negative y into it, it changed it to a positive y, then this is going to be the symmetric about the y-axis. This graph also, if you look at Desmos, it's going to be, in this case, since it's a x equals the y squared, it's an inverted parabola, so it looks a little bit like this, and I wrote y-axis, and I said that that needs to be then the x-axis. I'm sorry. So this is going to be symmetric about the x-axis. Now the next one that I have, if I look at the fact that this is going to be my squared terms, if I substitute negative x, expression squared minus y to the third is equal to 4. If I simplify that, then I notice that this is going to just change to x squared minus y to the third equals 4. And if I look at this on Desmos, it looks a little bit like this, where I have a function, and then it starts off here and it comes down. And again, and when I talk about Desmos, Desmos is an online graphing calculator, and it's found at desmos.com. And we'll be using that sum in our graph. But this is going to be the symmetric about the y-axis. And then the last one on this one, if you notice, both of these are going to be squared. And so when I put in a negative y expression squared is equal to a negative x expression squared is plus 7, both of those values will change to the positive. So y squared is equal to x squared plus 7. This one also looks a little bit like where my x and my y axis, where it looks like it's actually a hyperbola, where it's going to be opening upward and it's also going to be opening downward. And this one would be then reflective about the origin. And again, the key here is going to be looking at where the values are squared. To solve those, when I look at even and odd functions, even functions will always be symmetric about the y-axis, and it'll also just show, and this is the part that you will be tested over, you will need to know that if I'm going to look for an even or an odd function, I'm going to replace f of x with f of negative x. If that value doesn't change, then it's going to be then an even function. If I substitute f of negative x and it changes the whole function, every sign gets changed to a negative, that means it's going to be an odd function, and it's also going to be symmetric with respect to the origin. So in this case, when I look at the graphs here, if this one, because of the fact if I look at this point, if I've got this point here, and then I have a corresponding point over here, then that means that this is also symmetric about the origin. Okay. In this case, if I look about symmetric about the y-axis or the origin, because it stops, this one is neither. But then I look at this example where I have then it looks the same from the left to the right. This is an example of an even function, which has got to be symmetric about the y-axis. AXIS. So the first one where it was symmetric about the origin, this would indicate that it's an odd function. This one is symmetric about the y-axis, makes it even. So this is also a great example of what it looks like. Let's do a couple problems that will kind of hopefully make sense. So if I'm determining whether it's odd, even, or neither, the first thing I want to do is I want to take my function, I want to find f of negative x. And if I find f of negative x, that means I'm substituting this in negative x in for x. So I have a negative x expression to the third power plus 6 times negative x. And then I'm going to look to see what happens. When I take a negative and I cube it, that means that I will end up, that negative will stay. When it is to an even power, it will go away because it cancels each other out. So in this case, this is simplified to negative x to the third. Then I have plus 6 times a negative x, and that means that I have a minus then 6x. If I can factor out a negative from my equation, so if I take out a negative, and then I have x to the third, and then I have plus 6x, and I can put the negative out in front of my parentheses, and inside everything is exactly like my original function, then that means that I do have a function that is odd because of that negative. So in other words, it's an odd function, and it's also going to be symmetric about the origin. Okay, if I replace g of x with g of negative x, I'm going to substitute in here. I'm going to have negative x to the 6th power plus 2 times negative x. And so again, when I take the negative x to the 6th power, then my negatives will cancel and I'm left with just x to the 6th. When I have 2 times a negative x, I have a minus 2x. Now here's a clue. In this case, the one before, if every sign changes, then I know that I can factor out the equation. I'm going to get what I had originally back. But notice on this one, the first one changed, but the second one didn't. So if I try to factor a negative out, then I'm going to have to change this one to a minus 6x, x to the 6th, but it's going to be plus 2x. And notice that's going to be different than what we had from original, and so this one would be an example of where it's neither. Okay, and there's also no symmetry. Now the last one we do, if I find h of negative x, then I'm going to have 3 times negative x expression squared plus 3. And in this case, then I'm going to have, I know that I have negative x to an even power. That means it's going to cancel out. And so I'm just going to have 3x plus 3. Notice I don't have to take, if it doesn't change at all, if my, 3x squared plus 3, if this equation does not change and it is the original one, then I know that I have an even function. It's also symmetric about the y-axis. The next part we're going to talk about piecewise functions, and piecewise functions are going to look like they're put together, and so that's kind of how I always think about the piecewise, is just functions that are pieced together. And this first one, this one is telling me that I have f of x is equal to 3 when x is going to be less than 1. And so in other words, this is that constant line. This is the equation f of x, or remember it could be y, is equal to 3. And so I would write from this point, from anything from -1 on or to the left is going to be then this constant function of just 3. My second equation from -1 until infinity, for when x is greater than -1, is a linear equation. So this is the equation, remember I could write it as f of x is equal to x minus 2. I could also write it as y equals to x minus 2. But then I'm gonna find out all of these amounts, and so when you read these, you need to go ahead and think about that in terms of which values you're dealing with. The very first one is the domain, and so the domain I'm going to look for, remember, the x values. And so my x values, if I start off here at the left, I'm going to have negative infinity. This arrow indicates it goes on and on, so that means it doesn't. It's going to continue going on to the negative infinity. And then if you notice, at 1 I've got a break, but it's constant. I mean, I have a value for all of my x values. When x is -1, the value is actually going to be 3. And as soon as it's a little bit bigger than -1, then I jump over here to this linear equation, and then it's going to go on and on for infinity. So my domain for this function would be -infinity to infinity. My range, though, is different because those are going to be my y values. Okay, so I'm going to look for the lowest y value I have, and notice that it's going to be that I'm never going to get any smaller than -3. So my smallest y value will be -3. Then I'm going to go on because this line continues on. That means it's going to be my y value will go until infinity. I know I put a parentheses here, but notice here at 3, if this point does not include 3, I will also put a parentheses here. If this had been the solid dot here and an open circle here, then it would be a bracket. But in this case, since it doesn't include -3, that means my range is going to be just the parentheses, -3, infinity parentheses. I'm going to put C down below for my intercepts. So my intercept for my y-intercept, remember, that means that x is going to equal 0. It's also going to be then the place where it crosses my y-axis. So in this case, if you look, it looks like I cross my y-axis at -2. So my y-intercept is equal to -2. If I want to write it at the point, then it would be then at 0, -2. On my x-intercept, remember, an x-intercept, that means that y equals 0. It's also the place it crosses my x-axis. And so in this case, it looks like it crosses right here at 2. So it's going to equal 2, or it's going to be at the point 2, 0. On D, it says the intervals in which f is increasing. Well, it's constant up till the point where we change and we do the new piecewise function. So this is going to be my interval where it's increasing from left to right hill. And so we're also going to go increasing, decreasing, and constant. So on D, I'm going to start off with increasing, and I'm going to write it as my interval notation. So it starts at -3 and it goes to infinity. It will not include -3, so therefore I must put a parentheses. Then I'm going to go by decreasing, and if you notice on this one, this is going to be where it's constant and then it changes to increasing, and so there's no place that it's decreasing. But constant, it's going to go from my -infinity all the way up to -1. Now remember, be careful, don't use 3 because the 3 is representing my x value, which would be this point right up here. So in this case, I'm going to be constant, C-O-N-S-T maybe, from negative infinity to negative 1. And it's also going to include negative 1 because this is a solid circle. So I'm going to have a bracket and then I'll have a parentheses. The next one on E, I'm looking for f of negative 1. Now this means, because I'm looking at f of x typically, that means x is replaced with negative 1. So they're looking for what the y value is when x is equal to negative 1. So when x is equal to negative 1, then I have a choice. I have to come up or down, and this one's a solid point. So that means my y value at that point would be then 3. This is different though. This is saying where is my value for y equal to negative 1? And so in this case, I'm looking for y. It's my y value, so I'm right here. Where is my graph crossing here? And if you notice, it's crossing at the point when x equals positive 1, because it's the point 1 comma negative 1. So, and this one, that means that I would go comma and then, or semicolon, x equals then 1, 1. F of 2, so when the x value is 2, if you notice, then the y value here is 0, so f of 2 is going to be 0. And the value for which f of x equals 2, in other words, I'm looking for where it crosses, so I'm looking to see right here, and it looks like this. Remember, I can put it back into my equation, because I know that I'm going to have f of, this would be then 2, this would be the same, let me put it over here, h. This would be the same since f of x equals 2 and f of x is going to be 2 is going to equal then my equation x minus 2, and then I would add 2 to both sides. So x is going to equal then 4. It could also show that with my graph. If I came up here and that looks like the point 4 comma 2. My next equation. So this is also graphing. This is where we want to graph equations. So in this case, we're looking at two different equations with a critical point that's happening when x is equal to 2. So notice this first one, I'm going to graph when f of x is equal to a negative x minus 2 if it's going to be less than 2. And so if I think about it, I'm going to have my x values here, my y values here. I would also think about the value, or what is like what's happening, like I had 0 and then 1, and then I'm going to include 2 because that's the point that it's going to stop, and then I graph that, okay? And so in this one, when x is 0, then I would have minus 0, 2 minus 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 2. Okay, my range is my y values, and so if you notice that this is my lowest value right here that I'm ever going to get. And remember, that was also the point when x is equal to, when x was equal to 2, y was going to equal negative 4. So I know that my smallest value will be negative 4, and then it's going to be increasing. I'm going to have all values larger than that, so it's going to be 4 to infinity. And then I'll also put my parentheses with infinity, but remember right here, it includes that point, and therefore I must put a bracket there and not a parentheses. My last one is called the difference quotient, and this is a great problem because it's kind of like like a beginning of kind of like how we look at our slopes and our derivatives, so it can play a lot of factors into more advanced equations. So when I look at this equation, when I do the difference quotient, what I'm going to do is I'm going to substitute x plus h into my function, and then I'm going to subtract it from f of x, and I'm going to put it all over h. I'm going to give you a clue that when you do this and do it correctly, you should be able to cancel out the h and have it there would not be a fraction. So when we do this, let's look. If I have f of x plus h, okay, remember I'm going to go to my function, and I'm going to say that is x plus h expression squared. I don't have x with the 2, so it's just going to be plus 2. Okay, and then I'm going to put it into my formula. So I'm going to start off with f of x plus h, which is going to be then x plus h expression squared plus 2. But then I'm going to subtract f of x. Now, what I would encourage you to do is put it in parentheses or put a bracket there, because you're subtracting the entire f of x. So it's going to be x squared plus 2. And then I'm going to have this all over h. Now, the next step will be to go ahead and distribute the negative, but also we're going to find out what x plus h is expression squared. So to do this next step, I'm going to write this as x plus h times x plus h. Okay, I still have that 2 that I don't want to forget at, but when I multiply this, I'm going to start off with and multiply like with FOIL. So I'm going to start off with x times x, or x squared. Then I'm going to have x times h, so it's going to be plus xh. Then I'm going to have my inner terms, which is also another xh, x times h. And then I'm going to have my last term, which is h times h, which is going to be h squared. I still have this 2, so I'm going to go plus 2. But then I'm going to distribute my negative into my second equation. So I'll have a minus x squared and a minus 2, and then remember everything is over h. And now I'm going to go ahead and just start simplifying away. Okay, so on the very first one, I'm going to take my top part of my equation, and I'm going to say, well, I have x squared, I have xh plus xh, that's going to be plus 2xh plus h squared, so I've got rid of those. I'm going to have plus 2 minus x squared minus 2 all over h. And now I'm going to start canceling where I can. So I can cancel the x squared with the x squared and the 2 with the negative. And then I'm left with 2xh plus h squared, and that's the only thing left on the top, all over h. And so the last step then is to go ahead and factor out an h, or just remember you can cancel. So I'm going to take out an h, and I'm going to say that's 2x plus h, because I have h squared all over h. And now when it's in this stage, I can cancel out here and here. So my answer then is going to be 2x plus h. Okay? Keep in mind, I told you this would happen, and if it doesn't happen, then go back and look to see what happened and see if you may have missed. So it's so easy to maybe miss like a constant that's being added into it. So unless this case, after you simplify it, remember I should be able to have an h in every one of my terms, where I can factor out an h in the top and then go ahead and cancel out. Hope you have a great weekend. I hope we'll see you on Tuesday.